Hey guys, what's up? Today I am going to explain you the difference between series circuit, parallel circuit, voltage divider, current divider, and the Kirchhoff's law. And this is going to be a brief summary because it's an electronics refresher for the Internet of Things. So let's start. Well, we're going to make division. Sorry. Okay. Well, first we are going to start with the series circuit. A series circuit, it's going to be like this circuit. Here we have one resistor. Here we have another resistor. Here we have another resistor. Here we have our battery. And here we have our current. We're going to term the resistance as R1, R2, R3. And what are the rules for this series circuit? I'm going to explain you now the rules. Well, the rules for the voltage and the total voltage is going to be to the voltage in the resistor 1 plus the voltage in the resistor 2 plus the voltage in the resistor 3. So here we're going to have here our voltage 1, our voltage 2, and our voltage 3. And the total current, well, the current in a series circuit, it's going to be the same here. Here we have our current 1. It's going to be equal to current 2 and to current 3. So the current is going to be equal in all the circuit. And the total resistor is going to be the sum of all the resistors. And here we are going to make the contrast with parallel circuits. Okay, parallel. A parallel circuit, it's going to be like this. We're going to have our resistors in parallel. Here we have our voltage, our current. Here we have our total current, our resistor 1, our resistor 2, and our resistor 3. Here we are going to have our current 1, current 2, and current 3. And what are the rules for a parallel circuit? I am going to write them down now. Well, the rules for the voltage is that the total voltage, well, the voltage is going to be equal to the voltage 1, the voltage 2, and to the voltage 3. Our voltage 1 is going to be here. So if you put your multimeter here, you're going to have the voltage 1 here. Here you will have the voltage 2, the voltage 3. So if you want to measure, you have to know that you have to put your voltmeter here and here, because here it's the negative and here we have the positive value. The total current here it's gonna be the sum of all the currents. E1, E2, and E3. And the equivalent resistor, or the total resistor, it's going to follow this rule. It's 1 divided by 2 plus 1 divided by 3. So here we have the contrast between the rules of series circuit and parallel circuit, and I'm going to explain you now the voltage divider and the current divider. That maybe when you are going to be implementing your circuits, you are going to have a lot of voltage dividers and current dividers. When you are going to connect your sensors, you probably are going to find this situation. Okay, voltage divider. Yeah, if we have our circuit like this, we have a resistor here. If we call this resistor 1, resistor 2, and here we have our voltage, our input voltage. Here we have our current, and the output is going to be located here because we are going to divide the voltage, and the voltage of the output, it's going to be the voltage of the input multiplied by R2 divided by the sum of the resistors, of the values of the resistors. So the voltage is going to be located here. Output voltage, if you put a voltmeter here, you're going to measure the voltage here. And on the other hand, the current divider, it's gonna be like this. So here we have, for example, a parallel circuit. We have the current 1 and the current 2, and the total current, and the current divider rule says that E2 is going to be equal to the total resistor. Well, the total resistor, it's going to be this is R1 and this is R2. It's going to be the equivalent of the parallel of the resistor 1 and 2. The equivalent you can calculate using this equation, and resistor so these are the formulas for using this, for finding the value of this current and for finding the value of this voltage. These are fast formulas. That is the voltage divider rule and the current divider rule. And now I am going to explain you the Kirchhoff's law. We have 4 circuits: the voltage Kirchhoff's law and the current Kirchhoff's law. So let's start with the Kirchhoff voltage Kirchhoff's law. Here, this E actually, oh sorry, 10-minute place mistake. Kirchhoff's law. Kirchhoff's law. So the voltage Kirchhoff's law says that the sum of all the voltage in a closed loop circuit, it's going to be equal to 0. Oh, damn it. And then current Kirchhoff's law says that the sum of all the currents in a node, it's going to be equal to 0. So for example, if you have here this circuit, and here we have 9 volts, for example, and here we have 1 km ohms resistor, and here we have also 1 ohms resistor. The sum of all the voltages here, this loop, it's going to be equal to 0, and the sign here is going to be plus minus because the current is going to follow that direction. The input is going to be with the sign plus, here also plus minus, minus. So here, following in the resistor one, we have that we have voltage 1 here we are going to have our voltage 2, here we are going to have our voltage 3, and the voltage 1 plus the voltage 2 plus the voltage 3, and in this case it is going to be, because the current is going to find the minus sign, it's going to be minus the total voltage, it's going to be equal to 0. So the values here, so summing all these resistors, we are going to have 1k plus 1k plus 1k is 3k, the total resistor, and using Ohm's law we have that the current it's going to be equal to 3 milliamps. You can calculate using the Ohm's law that says that resistor by the current it's going to be to the total voltage. And so if we have here 3 milliamps and 1 case, so voltage 1 is going to be equal to 3 volts plus 3 volts also, because we have 1k resistor also, 3 volts minus 9 volts, it's going to be equal to 0. So this is the voltage Kirchhoff's law. And in the current Kirchhoff's law example, here we have one node. Here we have current number 1, current number 2, the current number 3. Yeah, the sum of all these currents are going to be equal to 0 according to the current Kirchhoff's law. And 1 plus 2 and plus the current 3, it's going to be equal to 0 according to the current Kirchhoff's law. And for example, here we have a node, so the current from this direction, from this direction, from this direction, it's going to be equal to 0 according to Kirchhoff's law. So well guys, this is all for today. See you in the next refresher tutorial.